this data set, which you should copy into your Excel. And you can copy it from the data for week 3. It's in Canvas. Or you could just copy it as you see it right now. And the first step I want you to do is to do a regression model based on that time period and the items sold. Then create the forecast based on that regression model. Then using this historic data that we have, calculate the absolute error, absolute percent error, and squared error, and take the average of all those to get the MAD, MAPE, and MSE. If you can do that, you can probably do at least one of the homework problems. And then what changes if you copy this and put it in another worksheet? Like, so this is linear regression. Label the tab linear regression. Then I'm going to add another tab. I'm going to call it moving average. And then I'm going to label another tab and call it exponential smoothing. So we're going to do all 3. But if you fill this one out right, it's just copy paste, erase the forecast column, and put let's say we're going to do moving average for 2 periods. And let's say we're going to use, well, just set it up for exponential smoothing. You pick the alpha, but we should be able to change the alpha. In each case, you should have a graph. So we see what it looks like. Who's done already? I want to be impressed. See what you get for being in the front row? We don't need all those decimal places. That's the first thing I look at. But I think it looks pretty good. Yeah, probably reduce the number of decimal places to like 1 decimal place for those things. Only because, yeah, we don't need that precision if we're talking about items. Who else is doing it? How are you doing? This is the walking around teaching part. All right, you're still starting?
Yeah, I got it.
All right, you got the graph. Did you get the regression?
The LinReg.
Yeah, go to, remember you go to chart options. There we go. I would make a scatter diagram instead.
Scatter?
Yeah, because right now you've got the x-axis there. If you make a scatter, it chooses one as x. There you go. Now, well, it's still made the x that way. Delete that whole thing. Delete that one too. No, that one, well, that does have 1 too, but you didn't copy that 1. That's all right. I think that should work because it's still numerical. Now go to, click on the chart, chart design, go to quick layout, f of x. We're tired. Look at you. Go to there. Get fx. Which is, now you got the equation. How are you? No, what you want to do is copy, highlight time period and item sold. The whole column, including the titles, not the whole row. Yeah, there we go. Go to insert. And then go to scatter diagram. Yep, go to scatter. This is the first one. Now you're going to probably want to move it somewhere. Then go to quick layout. Do the FX. You got a scatter diagram? Quick layout. Do the FX option, which is great. Get out of the way. Now you got your equation. Right there. All right, go sit by Syed and right over there, and then you guys can work on this together. And that way I can get you both at once. All right, let me see how the Swedish folks do. Swedish slab, Scandinavian bro. Insert. That's okay. So it should be scatter diagram. And pick the first option. Sorry.
Which one is?
I would highlight all this. And then go insert. There, it's right there. So highlight it and then hit insert and do the scatter diagram. I'm sorry? Okay. How about this guy? You gonna help this guy too? I know. How you doing? Well, first of all, highlight the time period and the item sold. All the way down. Now you're saying I want to graph that. Okay. And say insert. Probably different. It does look different. You got me. Press it by hand. Okay. Do you have a laptop that you can?
No, I don't have one.
This is Excel for the iPad.
Yeah, I think so.
Does it have an Apple logo on it?
Yeah.
Okay, good, yes. Graphing on an iPad. Excel, graphing on Excel and iPad.
Okay.
Is it, are you using the cloud-based one?
Yeah. The one that the school provided.
Right. So it's 360. You can download it. You can download the Microsoft Suite to any device. You can download it and get the right version if you have space.
Oh, okay.
I mean, is it an iPad Pro?
Yeah.
You should be able to do that.
Okay.
Yeah, now you go to, click on chart. And you go up here where it says, recommended, not recommended. Wait, let me show you how this is done. You know, just note to self, when I cover this in class one time and there's data there, go home and try it. Because, let's see, we have a lot of people who play sports here, right? Do you want to, on the day of the game, try something for the first time? Or do you practice it? Same principle. I know, I'm being like Captain Obvious here. I would highlight the data. I would go to Insert. I would go to Recommended Chart. If I don't see a pivot, if I don't see a scatter diagram, which I don't, I'm going to say Cancel. And then I would go to here where it says Scatter Diagram, and I'm just going to pick the first one. And it draws this beautiful little scatter diagram. So I move it over to where it is. I made it bigger so you guys can see it. But now I want my regression equation in there, don't I? So whenever, let's say right here, if I click on an object like a graph, it gives me, I can change the colors and make it black. I don't care how you make that. But what I'm interested in is go here. It always gives you an option for chart design. Go to chart design, and you have what's called quick layout. Quick layout has a variety of different options. If you click on them, you can see what it looks like. If you're not sure which one to use, wait till, try them all until you get to the one, then click on it with the FX, because this gives me the regression equation in the R squared right there. I don't need the legend because I know what it is. You should, let's call it items sold. The y-axis will be number of items. If I could spell it right. Items. And then this is going to be, X will be time period, or if you want to just say months, you could say months, because I think it's 1 through 12. It implies it's month. Okay? Now you've got a regression equation. It says 5.0804 times X, X being the month, plus 118.73. That would be your forecast. So put that formula in there and fill in that whole column. I can't spoon feed this to you. I mean, I can present it. I can provide you videos so you see how to do it. But at some point, you've got to stretch, try those muscles out. It's not these muscles, it's this muscle, as you have obviously done. You must use Excel a little bit more often. Business majors, you should get into the habit of using Excel. And how do you get into the habit of using Excel? Go ahead, Alice, tell us.
Take accounting classes.
Basically, just do it, right? Yeah, and if you don't know what to do, you Google it. And if you don't know what to do, you ask someone that knows what they're doing. And then eventually you get good at it. And there's always someone better and all that kind of stuff. Do you know how to put the formula in now that you have the equation? And I like to, this is just me because I do it the same way every time because I'm boring. Oops, I'm sorry. I don't want to do that. I want to say home. I want to make that bold and I want to make it, not that, I don't want fill in it. I want to make the color like a maroon color. So it just stands out. What does the R squared mean? Anyone? Bueller?
It's the coefficient of determination.
Oh, wait, Thana's saying something. She's going to answer the question, and she's not even here. Go ahead.
The R squared is the coefficient of determination.
It's a coefficient of determination, yes. You get points for knowing that, but it really says that percent of the Y data is explained by the model. It's also a measure of model fit. So I'm explaining 23% of the variation. I'm not really excited by 23%, but I'm not unexcited by it. And I look at the graphic. The graphic kind of looks okay. And let's see what the absolute error, squared error, and MAPE is then. So your next job is to fill in this forecast. How do you fill in the forecast? I'll give you a shot at it. There's the equation. There's the blank space. Put it in there and copy it all the way down. Anybody do it yet? Oh, you did it all. Yeah. Who wants to go sit by him and learn? Anyone? Okay. I didn't know I'd come and sit by you. You done too? Don't calculate stuff there. No. Use Excel. Use Excel.
I always mess up when I like copy and paste, like in all my accounting classes every
Well,
time.
let's try it. Show me the first one. Let me look at the first. No, try it for the first one. Let me look at it. What are you doing? And don't copy paste it. These copy paste is hard, but create the formulas. Right? Equals. Here, let me do one, just so you see how it is. And I can't show you this more than like 3 times. I think we did it like once already, and we're doing it like once again. At some point, whose responsibility is it to know how to do it? And it's recorded. So if you're like, hey, professor, show me a third time, oh, I can go and listen to his boring lecture again, or dial into that part. I would like equal sign. Equal sign tells Excel, hey, I'm about to do a calculation. And I'm going to multiply 5.0804, and then times is the asterisk, and I want to multiply the x. X is the time period or the month. So I click there. So now I have C5. I write plus again. And now I've got to write the y-intercept, which is 118.73. 18.73. And I hit enter, and it gives me an estimate. I don't want an estimate with so many decimal places, so I'm going to reduce the decimal places to 1. Now, do I just do the same thing for each row?
No.
Yes, exactly. You just drag it down. That's the nice thing about Excel, is you don't have to do the calculation every time. And you shouldn't, and Gabriella, I was glad you did that, because a lot of people will calculate it on their calculator and enter it in Excel.
That was me. I didn't know how.
No need to do that. This is like the greatest calculator. It does everything. And it's a calculator for lazy people. Are you lazy? I certainly am. I don't want to go through 100 rows doing this. I'd rather do it once and then, as Abu said, click on that little bottom and then drag it down, and it will repeat the formula. If you look, the only thing, the variable in there is C5. When I go down, it'll be C6, C7, C8, C9. So it's picking up the different, and it calculated everything for me. Can you get to this point now? Or tell me when you're there or not there. How about you, James? Are you getting it? Leanne, you okay? How about anybody want me to come and look over their shoulder? Let's put it that way. Matthew, how are you doing? Okay. We're able to graph it? Oh, good. Excellent. Now, what do I want to do? What's the error? or the absolute value of the error, because we're never going to just use error. We'll just look at absolute value of error. So I take absolute value of either actual minus forecast or forecast minus actual. Can we do that? Type that in there. Equals ABS. That's the form that says, now I have to put parentheses. It says whatever's in that parentheses, I want to take the absolute value of it. So I'm going to take item sold, which is the actual, minus the forecast. Boom. It gives me 4.8104, and I want to reduce that to just 4.8. I don't need all those decimal places. And then I drag it down, and it does all the calculations. Thank you, Excel. I'm lazy. I don't want to do all those things. I want to do it once and then drag it down. There we go. Absolute error. What if I take the average of that column? I'm going to make it a little bit smaller so we can see the whole thing, okay? I would say equals, well, first of all, did everybody get to this point? Say that louder. You want to see the calculations in the first row? Absolute value D5 minus E5, because that's how I have it. If you have it all in row one, your cells will be different numbered, or you have it in different parts of the thing, but this is how I did it. And if I want to see how I calculated it, you go into the little window and calculate it, and it says, oh, those are the two cells. And in case I picked like the wrong cell, like I made that mistake, I can like just go and click on the edge of it and move it up and fix the formula. I don't have to backspace or, you know, or I can go and edit it in the formula bar. But I can actually move those little boxes around if I pick the wrong one by accident. Yes? And then we use the Abu method of just like clicking on that little square in the corner and dragging it down. And what it will say is each time I go down a row, I'm going to change all the things by one row. So it'll calculate the corresponding thing. So is everybody here? You got it too? Say it louder. You just got to pretend like even with hearing aids, I can't hear you. Thana, I know you're here, aren't you?
Yeah.
All right. Probably you and Elmas are probably like, you know, okay, I think I'll go get another cup of coffee at this point. Now let's go to the bottom. We have absolute deviation. If I take the average, it becomes mean absolute deviation. MAD, it becomes that, it's saying on the average, my forecasts are off by this much. That's a good thing to know. If you're happy with that, that much, then you can say, I have a good forecast. It's that simple. And who determines that? You determine that. You're driving the forecast car. There's no set rule. It really depends on the context of what you're trying to forecast. If you're forecasting something that each one costs you $10 million, you probably want to be really accurate. If you're forecasting where each thing costs you 2 cents, close enough is close enough, right? So it's in the context of the value of what you are forecasting. And then if you have a little bit too much one month, you know, if you forecast high one month and the sales don't come in there, well, you're going to have extra inventory, but that you don't build less next month. And if you do it kind of right, half the time you're high, half the time you're low, and it all equals out over time. So you just make less or make more depending on what it is. It's the big swings that kill you. That's what makes you go out of stock. Okay? So this is all for planning. I'm going to try to guess for this one item, how many I think I'm going to need. So if I go to the bottom of that column and I say equals, which means tells Excel I'm about to make a calculation again, and I do average, and then I highlight the whole column, all the numbers in that column. It says I'm basically going to add all those numbers up and divide by 12, which you could add all those numbers up and divide by 12, but isn't this easier? Again, I'm lazy. Not to pick on you again, but you would have like added them on your calculator and no, don't do that. That's painful. And it takes you longer, doesn't it? So you've got to force yourself to learn to do it this way, only because you can crank out much more work. Now, here's what I do. I write underneath that MAD, because I know that means mean absolute deviation, and I'm sure you do now too. And then I make that bold, and maybe I highlight it in yellow to say that's one of my forecast accuracy. You don't have to highlight in yellow. You don't have to make it bold. You just have to know where it is. But all my charts all tend to look the same. That way I don't have to think and make it creative. And I would say if you are going to do a series of different things, I don't care what the formatting you use, the colors of the graph and all this, make all the graphs kind of like the same format. Make all the charts kind of like the same format so that when you're presenting, people are used to looking at whatever your color scheme and whatever your organization is, and they're not trying to figure it out every time. If I send a blank Excel sheet out to 20 people in my company that work for me, and I tell them to fill out the charts from their own local stuff and send it back to me, I will come back, I will have 20 different formats. No one will just fill in what I have. Well, no, he doesn't want to see it this way. He wants to see every different row a different color. I'm like, okay, fine. Emma, you work, you've seen that, right? It's just human nature. Oh, I want to make it look pretty the way I think it should look pretty, not the way you think it should look pretty. Right. Is everybody here? Yay. Absolute percent error. Well, I got my absolute error. I want to find out the percentage of the error, because remember what we said last time is if I have products of different volumes, MAD is very good for looking at one, but I can't compare item 1 and item 2 and item 3 because the one might have 100,000 in volume and the other one might only have 1,000 in volume. So the MAD is going to be an actual error. So it's going to look like the one that has a higher volume has a higher error, even though the percentage error might be smaller. So we want to find the percentage. And you always take the difference. You take something of that you want to find the percentage error of, and you divide it by what? What it should be. In this case, what it should be is the actual. So here's what we're saying. We're saying equals the error, 4.8 in this case, and I put divide, and I want to divide it by the actual, which is the item sold. And if you want to write actual instead of that, if that helps you better, write actual there. I know it's actual because that's what was actually sold. And I get this number, but I really said I wanted it to be a percentage, even though I know 0.04 is 4%. But if I make it a percentage, it makes it 4%. If I want to add a decimal place, let's add a decimal place. And then copy it all the way down. Not all the way down. Watch what all the way down means, though. Not necessarily to here. Right? Because that's my total column. Now, here's another trick. Abu, do you know this trick? Double click on it. And it fills in what it thinks you want to fill in all the way down. But of course, here it gives me, well, wait, we don't have numbers there. It gives me funny values, but I don't want it to do that. I want to calculate the average again. So I got all my percentages. What's the average percentage error? That would mean mean absolute percent error. Mean is average. It just sounds more aggressive. It sounds mean. Someone should laugh. All right, so what am I gonna do? Equals average of, and if I here's two ways of doing it. I can do it again. I can highlight the whole thing. No, it didn't like that. Why didn't it like that? Because I went backwards, probably. Oh, because I didn't type average all the way. It said average. So it got confused due to my human error. Again, the best way to learn this is to do it once every 3 years. Exactly. You should do it, you should use Excel more often. You'll remember, it's like a language, right? If I know, I don't know, how do they say Thursday in Swedish?
Tisdag.
What is it?
Tisdag.
Did you say it right? Okay, now if I just like hear it once and I say, okay, next year I'm going to remember that, will I? No chance. I have to like use it a lot. It's the same thing with this. This is for you. And you're tired as all heck. I can't believe you're here. Okay, so I put that in there and I put a closed parentheses. Sometimes if you don't put the closed parentheses, it doesn't do anything. 1845. The other thing I can do is I can copy it sideways from here, but it gives me 0.2 because it doesn't think, because that format that I'm copying over wasn't in percentage. I would have to put it in a percentage. And I would add a decimal place. Now it says my percent, my MAPE, M-A-P-E, my mean absolute percent error is what? 18.5. Can I live with that? It's up to you to decide. Well, if you can live with 25.9 as the absolute deviation, and that's 18%. If you can live with that, that's good. You decide. You have to decide. Now, let me make that bold. And rather than make them all, I try to give it a contrasting color just to give it a contrasting color. And that's too dark. If you're going to highlight something, make sure people can read it from across the room. I don't care what color you make it, but just make sure people can read it. There we go. Now, the only thing I have to do now is square the error and get the MSE. So I say equals. Now, how do I square the error, 4.8? I can do I can highlight that cell times that cell again. I can do that, or I can say equals, and I scroll over to their absolute error, 4.8. Yeah, that's what I want. And I can use the thing above the 6, shift the thing above the 6, the little hat thing, which means, hey, what's after this is an exponent. And the exponent for squaring is 2. And I put it there, and ooh, I get a bigger number, but I don't want all those. I just want one decimal place. And the rule of thumb is you want one more, at most you want one more decimal place than what it is. There's no decimal places in the actual, so I'm adding one more decimal place. If there was one decimal place in the actual, I'd probably make it to 2 decimal places. But it's a rule of thumb. What is a rule of thumb? It's a general guideline you don't necessarily have to follow. If you wanted 0 decimal places, I would be okay with that. If you wanted 3 decimal places, I'd be okay with that. If you wanted 8 decimal places, I'd say why. We don't need all that degree of definitiveness. I copy this all the way down. And I'm going to copy it from here. I'm going to do Control C, just like in Word. Control V, it's a Microsoft product. And now it says my MSE is 998.9, like basically 1,000. But what does that tell us? MSE is harder to determine because you squared the error. The other two, MAD and MAPE, are more intuitive. That's why everybody uses MAPE. But before there was MAD and MAPE, all people had was what statisticians told them, and that was MSE. That means something to statistician because it tells you the squared error. It's like standard deviation. I tend not to, if I was to show that to executives, I think it would confuse them unless they had a degree in statistics, maybe. But I have a degree in statistics and I don't like looking at it. If I'm doing forecast accuracy, I want to look at MAPE. I just want to find out how off are my forecasts by a percentage of the actual. 18.5%? Well, you're doing forecasting for the first time. You're all thinking that's too high. In consumer goods, that's probably okay. Because we catch it with the manufacturing, right? If I have too much inventory at the end of this month because we were off by 18% low, well, I'm not going to make as much next month, but I'm still going to try to make it to the forecast. So I got what I got. I'm going to make a little bit more. And if it goes 18% high, I've got some safety stock that covers me if it goes high. And so that's basically how you do it. It's the wild swings, the swings more than 30% that'll kill you. And then I think I'll make this one orange. Why do I make it orange? It's quite simple. I always do. Do you have to do that? No, make your own colors. Yes, sir. All right, say that again. Only in the absolute percent error. For the other ones, for the mean absolute deviation, I just want to find out how far off the forecasts are and take the average of that. That's mean absolute deviation is just how many units am I off on average? But the problem with that is if one product, if I have for one product, that's good enough. If I have 10 products and they'll have different volumes, let's say one has 100, one sells 1,000, one sells 10,000, my mean absolute deviation, I can't compare the two, right? So that's why we make it a percent, because now I can compare percents.
I mean, we have the same numbers before.
But not 51%, it should be 23, it should be just be 23. You want to take the formula here for squared error is just square the error. 4.8 times 4.8. Well, so 4 squared is 16, 5 squared is 25, 4.8 is almost 5, so it should be closer to 25 than 16, and it is. Yes.
What do you think your title, like, square error might kind of go long? How do you make it?
Oh, how do we make it? Let's say there's a thing called wrap text.
It's on.
Yeah, and if you didn't see what I did at the very beginning, I highlighted the whole column and I hit bold and I hit wrap text. So that whatever I type in there, it'll wrap it around. Now, sometimes it doesn't know where the word ends, so it wraps half a word. So then you have to make the columns adjust the columns to make it look nice. The whole point is making it look nice. This is not part of the class. This is just stuff that you should get for free. Anytime you do something in Word or write an email or do something in Excel, you should prepare it in such a way that someone else, like your boss or your boss's boss, can clip your work, put it in a PowerPoint without having to format it to look nice. It's just polite to do that. And it shows that you've got a business sense about you. Because I see stuff when you turn it in, like papers and whatnot. Sometimes I get a paper that's like one giant paragraph when it should be like 6 paragraphs. Use bullet points in business communication, right? There's 5 major points here. Well, you might put it like 1 parentheses and write it, and then 2 parentheses and write it, and it's all in the paragraph. But if you're going to say there's 5 points, use the numbered bullet points, 1 through 5, and then write the points that way. That way people can see it. It looks very clear to them. And same with emails. Professor Kaminsky has a habit. If you send an email that is not like kind of a good business communication tool, he'll send it back and he'll correct it and send it back and say, I'm not responding until you make this look more professional. Yeah. I'm not quite that bad, but I encourage people to get in the habit of, and it's a habit. It's not, it's not a natural thing for everybody. Do you ever see how other people take notes? I mean, some people are like, oh my God, that's so beautiful. And if you look at mine, if you look at my notebook, it's like, I guess it's kind of organized, but it's not like, if I showed someone else's that the 1 out of 50 that just like has 3 highlighters on their desk and, they're taking, and it's like, we could like publish this. I'm not saying you have to do that, but you want to make it easier for people to read and appreciate what you're doing. That's the whole point. It doesn't have to be desktop published and slick like it came out of a magazine, but it should be organized. And that's the whole point here that I'm trying to get across. All the numbers in the column should have the same number of decimal places. I'd rather see them all have seven decimal places than one have, one row be 2 decimal places, the other be none, and then, that kind of thing. And I don't know why, I always use a powder blue header, and that's what my charts look like, okay? The graph, I'm not real picky on graphs myself, but if you want to go here, once I've done all this, and I go to chart design, students like this, you go for that, and then I think there's even more you can look at. So how do you want to look at it? What makes it, let's see, where is the one with the zeros like that? That's cool, make it like that, I don't care. But I'm more interested in the labels and everything. And let's see. I'll just leave it like that. For charts, I'm okay with plain Jane for me. And even the tables are plain Jane as far as I'm concerned. But look, it looks nice. If I was to copy and paste that into a PowerPoint, it would look professional. And sometimes when you copy it, it'll take the grid lines with it unless you view, and if you want, you can turn off the grid lines. Now if I copy paste it, it'll copy paste it without the background grid lines. All right, how's that? Can you now do this problem? This problem just says on your homework, calculate the MAD, MAPE, and MSE. I've already given you the forecast. Can you do it? Yes, you can. You just did it. Will you remember it like Sunday when you go to do it again? Maybe, but we're recording this. So you didn't have to fast forward and stuff and hear all my stupid comments again. You go, wow, it's even less funny the second time. I wish you knew some jokes in Swedish, that would help. All right, so the next problem says, it's just the problem we gave you. It's just different numbers. Here's 12 months. Do the linear regression just like we did. Can you do it now? Theoretically, right? I mean, you're going to get there Sunday and like, look at, what was that again? But you know where to look. You know where to find it. You got some sense of it. If you really want to remember, do it tonight. Not you, but everybody else. You should wait and get some rest up. All right. Let's look at the next problem I want to do. I want to do moving average. We said what, 2? Well, here, there's no data here. What should I do? In this case, copy. Why don't I copy this data? And let me put the grid lines back in. And let me just copy the whole thing. Why am I copying the whole thing and not just the data? You'll see in a minute. I could do copy, Control C. I can go over here to the moving average one, and now I'm putting it in a different place, but I'm going to say Control V, and I can make it bigger again so you can see it. But it's still a regression forecast, and I want to use moving average, don't I? So what do I want to do? Delete my forecast. Well, now it shows me my error is 119 minus 0 is 119. The calculations are still there. What if I put a new forecast in here? Will it calculate all those things right? Let's say yes. Well, for the lazy person, is that a good thing? You got to be a little careful, and I'll show you why. We're going to do 2-month moving average. 2-month moving average. We did 3 in class. You could do 2, 3, or 4 seem to be the more popular numbers. We're just going to do 2. If you want to do 4, you can do 4. So I go here. I can't forecast January because I don't have 2 months of history. I can't forecast February because I don't have 2 months of history. I can forecast March because I have the January and February actuals. So I can't start at the top. I got to start here. And I say this equals, what was that formula again? I could add 119, 195 and divide by 2. But what was the formula we used to take the average? Oh, yes, average. Funny how that works. Imagine if you're doing this in your second language. So I just highlighted the 2 I want. I want to do 119 and 195. We're going to say my next month's average is the average of the actual sales of the past 2 months. So I get 157. It's already formatted to 1 decimal place. I'm like really happy. I've cut my work down. So if I click, double click on this, whoops, I don't need these. It fills it all in, doesn't it? 2-month moving average. Well, good for me. Except I've got errors in these first 2 rows where there shouldn't be errors. So what do I want to do? I want to delete those. But now when I look at my average of these things, it goes all the way to the top. I don't want to go all the way to the top. I want it to start at March. See the difference? And same here. So I hit enter and it changes. It doesn't change it by much. And here's 25.3. If I click on it, it shows the whole column again. And let me just reduce it to what I want it to be. It's still 25.3. It doesn't change it at all, I don't think. But that's okay. I just want to be accurate. Hey, the second one's taking way less time. Why? Because I already created the structure. That's the beauty of Excel. If you're going to do something over and over and over and over again, make sure you use the form. If you had to calculate it, you'd have to calculate them all again, wouldn't you? And that takes too long. I don't have that kind of time. I've got to watch TV. I got to go out with my friends. So I want to shorten the amount of time that this takes. I want to watch North Park soccer on the television. Men's and women's. Well, there we go. The table's done. What's missing? I want to see a graph. Oh, such a good answer. And I don't know, let's stumble through this. How do I do a graph? I think I want to insert. Why does this look funny? Let me escape here. Why does it look funny? Oh, because I'm not home. There's insert. Okay. I copy the time period, items sold, and forecast. And what do I want to do? I want to say insert. And let's try the recommended charts, just see what it gives me. There we go. I like this one. That's exactly what I want. It gives me items sold and forecast. Tells me which is which. Nice little line graph. Month moving average forecast. 2 month moving average. Moving average. And then if I want, I can put the other stuff in there. And look what happens. It shows me the graph. It shows me how the, I don't know, the orangish line starts 2 months later, it starts in March, and it kind of follows it. You know, because here's what happened. First of all, it took the average of these 2 months, so it's going to be about halfway in between. The next one, it goes down one, so it goes down, but it's still going to give an average of this and this, so it's going to be there, but then it goes down further, so it goes down again. The problem with these kind of forecasts is it lags behind reality a little bit. It's trailing reality. If this goes down a little bit later. If this goes up a little bit later. But the nice thing about the average is if you have wild swings, it doesn't go up to the wild swings, it kind of stays in the middle of it all. So it still reflects the dips and the peaks and the valleys, but kind of in a central way. The more, if I take a 3 month moving average, it'll be smoother. It'll be closer to a line. 4 month moving average, it'll be closer to a line. So, but that's one way of doing it. The problem with moving average is I can only do one period into the future. The regression, I could pick any month in the future, as far out as I want, and it will dutifully calculate it. The problem with regression is I'm committed to that slope. So if the slope is positive, it says every month it's just going to go up by the slope. The next month it's going to go up by the same amount of the slope. The next month is going to go up by the same amount. If the slope is negative, it's going to do the same thing, but go down by the same amount every month. This will adapt a little bit better. So the whole Winters method, remember that thing I told you to read because you should? Not because I want to grade anything on it. Look at the grasshopper is paying attention to our class. Getting a free education. There's one in the window. It's ADD, as Bulmer would say, kicking in. So really that's what you want to do. The whole Winters method combines regression and not necessarily moving average, but moving average on steroids, which is called exponential smoothing, which we're going to do next. It combines that and it combines seasonality. It brings it all three together so I can project as far as I want into the future, but it's a little bit more, it's way more complicated than the simple things that we're doing here. But it takes the two simple things and puts them together, and it's going to have to be more complex the way it puts it together. Got it? Okay. Exponential smoothing. What do I want to do? Well, hey, copying the whole table worked quite well the first time. Why don't we do that again? Even though you got to watch out in your homework problem, it's a different problem each time. The data is different each time. So don't copy and try to do the you know, if you look at the homework, here's the homework for the first one. Let's see, did I use the same data? No, I used different data. Oh man, for the second one. And then I use and then it's just, I have a column for moving average and thing. But guess what? The formulas are the same. If I did this whole thing, let's see, that's 12 months. How much is this? This is only 10 months. Be careful. But you can copy the formulas into the chart and change the numbers. Or you can just go and say, reprogram it again. Reprogramming it again is probably better for your, and I'm not asking for all three. I'm only asking for MAD here. Here, what did I ask for? I asked for MAPE only. So pay attention a little bit. You can do all three. I'm okay with that. You did MAP, you did more. Yes, ma'am. Say it again now. Word document? Oh, but you haven't downloaded it. If you look at it in Canvas, it's just going to show you that. Click it, double click, you see that little download? There you go. Look at you. No, but again, the first time you're doing it, right? All right, so let's do moving average now. Let's do moving average for the data that we have. Do I want to copy the whole thing again? Hey, that worked out well the first time. Let's do that. So I'm going to say copy, and I'm going to go to the exponential smoothing page, and I'm going to put it right there. I'm going to say here, boom, copy. But we know we're using a different forecasting method, right? So what do I want to do? I want to wipe that out because we're going to do something else. What's exponential smoothing? Oh man, I don't remember. Or maybe I do. I mean, if you teach this class like 13 times, you'll actually remember the formula. How do they do this? Throw them out. Forecast of time t plus 1 equals some alpha times the actual, I think, actual of the previous time period plus 1 minus alpha times the error. Or is it 1 minus alpha times the forecast? I think it's a combination of both, right? I think that's a formula. It's a mix of forecast and this. Remember this, alpha goes from 0 to 1. What does that mean? If I have the number line 0 to 1, it's all numbers 0 to 1. It's a percentage. If alpha is 0, the next forecast is the previous forecast, so it's always going to be flat. If alpha is 1, my next forecast is my previous actual. 1 month moving average, basically. Now, when I take a combination of both, I blend them. It's more adaptive or less adaptive, depending on what you look at. This is only if alpha is 1, it's a flat line. If alpha is 1, it's exactly the 1 month moving average, so everything lags behind. A combination of those smooths it out. One of those gives you the optimal value. And so you can change the alpha. So there's an alpha involved here. We have to put in the first month, you have to put what they call a seed forecast. Let's put 120, and I'm going to include that. You can put anything. You can put 150, you can put 133, you can put whatever you want to put in there, but put something relatively, since you know what it is and you have to seed it with something close. Let's say 121. Not going to make that much difference. So I got it. And it changed the ABS and all that. Now I like to make this red color so that we know it's a guesstimate forecast. Now for the next one, and what's my alpha? Ooh, I don't know. Let me put a column here, alpha. And then right underneath it, I'm going to put an alpha value. What should the alpha value be? Let's start off with 0.3. Okay. So my next forecast is going to be well, not there. It's going to be right here. Equals, what's that formula? Alpha which is H3 in my case, times the actual, the previous actual, sorry. I know, go away. Let's get rid of that. And the previous actual plus parentheses 1 minus alpha. Oh boy, this is a complicated formula, isn't it? Times the previous forecast, be 120.4. Now, if I copy this down, it's going to be wrong. Why? Because look at what I have here. I have HC3, H3, D3, right? The alpha is a D3. When I copy it down, it's going to want to put alpha at D4. So it's going to be using 0 as alpha. So it basically gives me just the previous forecast. It's got to be D3, right? So my mistake here was it cycles down each time. That's a good thing, except when you don't want one of the numbers to cycle down. Now I can anchor it. How do I anchor it? If I put a $sign between the H and the 3, it says if I cycle down by row, don't cycle down by row for this. The $sign says keep it there. If I put the $sign before the H, it says don't cycle it if I move it across columns. Don't change the columns. So if you really want to make it fixed, you can put a $sign before the H and after the H. But I know that for my own sake, that just one before the H is good. And here just one or after the H, sorry, between the H and the 3 is good. And I get the same number. Now look at if I copy it down 1, it changes it to 142. And it still says H3. Yay. So now I can copy this all down. And what do I have? It gives me my MAD of 31, my MAPE of 20.2, and it gives me my, let's look at MAPE. 20.2 for this. And if I want to change my alpha now, the reason I did that way, rather than just putting it in the formulas, I can change my alpha to 0.5 if I want. And it changes to 2. What if I make alpha 0? That's what's nice about Excel is you can do the what ifs very quickly. You just change one number and it'll work. A lot of power here. So let's say what's 0.6? 22.7, what's 0.4? Yeah, let's do 0.4, it's 21.5. What's my moving average? Was 25. What's my linear regression? 18. For this data, it looks like linear regression is the best, even though it's small percentage points different. Do you think you can do the homework now? Especially if I put this video in the announcement? It's long, you have to skip around and get to the right parts. But it shows you a little bit of Excel, it shows you, and you should learn some Excel. Excel is a good thing to know. Kaminsky will like it if you know Excel when you come into financial, principles of finance. And Hawkinson too. Some of those calculations are just hard to do by hand. You could do a regression by hand, but it'd take you, you'd be pounding on a calculator for an hour, what it'll take you like 2 minutes here. Thana, does that answer all your questions?
Yes, it does.
Perfect, good. All right, what time is it? What time does this class go till? 9:40? Oh, what do you want to talk about?
Actually, I may have another question.
Yes.
So at the last slide of the Excel, you want us to discuss the differential between a time series forecast and a regression forecast. Is that right?
Yeah, I've said it like several times in this week in both lectures, and I even said it today. The regression commits you to a straight line, which means every month the forecast is either going to go up or it's either going to go down. That's a negative of it. It doesn't react well to zigs and zags, but it also allows you to forecast far into the future. That's a positive. What happens with these other two? They react well to zigs and zags, but you can only forecast one period into the future. That's basically the answer to that question.
Okay, thank you.
Holt Winters, which I gave you a reading, which could help you in this answering this question, combines the best of both.
Okay.
It allows you to adapt to zigs and zags. It allows you to include a trend. It allows you to include seasonality, and you can forecast as far into the future as you want. So read that little article to get the full benefit. I guess you shouldn't read it just for your benefit. You should read it for question 4. Okay?
Okay.
All right. Oh, and I didn't do one thing on this one. I didn't make a graph on exponential smoothing. The graph on exponential smoothing is actually interesting. If we go here and I graph this, and I say insert recommended chart, and I really want to do the line chart again. I'm not going to label it just because I'm not going to label it. But look what happens. What happens when I change my alpha? Here, this really shows you what happens. If I make alpha equal to 0, my next forecast, my previous forecast, all my forecasts are 121. Is that a good forecast? That doesn't look good. It looks like I'm underestimating half the time, right? What if I made the forecast 1? Well, it's the exact same curve. It just moved over 1 unit, right? That's exactly what it's going to look like. So let's look at 0.5, halfway in between. It blends it a little bit. I think it's kind of okay. It gives me kind of a middle ground. It's kind of like low for several months in a row here. Maybe I want it to be more adaptive, so maybe I have to make it 0.8. So I make it 0.8. That looks pretty good, doesn't it? But my MAPE is 24, but it looks like, visually it looks better. I don't know, what does 0.9 get me? Well, you can't be sitting here for 1,000 items and going through each alpha and picking what you think it ought to be. But then here's, if Excel helps you, your ERP system like Oracle or SAP, which has a forecasting methodology, a forecasting module in it, you can say for my 1,000 items, I want to look at these 4 forecasting methods, Holt Winters being one of them, and you tell me which one is best. Not only does it tell you which one is best, it tells you the alpha, beta, and gamma smoothing constants for Holt Winters, and saves you all the trouble of doing this. And probably gives you some exceptions that said, you might want to look at these 4 items or these 10 items or these 100 items because something doesn't look right, or we're not able to get the. You just need to look at some pictures and some graphs and see if you're okay with this. So it gives you exceptions to manage. But this is a nice feature about Excel too. If you have something that's dependent on a smoothing constant, or something similar to a smoothing constant, if you program it right and you have it there, you can just change the number and it changes the curve. Look at, if you go from 0, very flat. If I make it 0.1, so the closer alpha is to 0, the closer it is to a flat line. And the more I make it towards 1, the more adaptive it is to the zigs and zags. So that's the advantage of exponential smoothing. You can you have a method, but you can also dial it in. If we go up to 0.9 or 0.85, that looks kind of good. But who decides what's good? You and your team, you and your boss, you and whoever's making the decision. It's your forecast. There's nothing magical about this. This is just a projection, a mathematical projection. You got to decide if it's useful for you. Now, could you use some of these methods to predict stocks? That's the question. Well, in my graduate class, I give the students some historical stock data. Like maybe I give them 8 months of data, but I give them another month that they're going to try to forecast. But we actually know what it is because it's past data. So I'm saying use the first 8 months or first 6 months to try to forecast the 7th month. We have all the data. And they use moving average, they use linear regression, and they use exponential smoothing. And I put some videos up just like this on how to do that. And you should see the comments I get on that. And I put a disclaimer. These are practice problems using real data, which is stock data, to practice forecasting techniques. And people will still write, this is the stupidest way to predict stocks that I've ever seen. You shouldn't be doing this, you should be doing, I'm like, yeah, I know that, but you missed that disclaimer where it says, this is just a way, you want real data, there's real data. And stocks are so unpredictable. Some stocks, I had like 12, maybe 15 different stocks over a period of 7 months, 2 years ago. Some of them are all over the place. Some of them show almost a straight line up. Some of them are declining, but with a lot of volatility. Some of them look like a W. How do you forecast that? So you get an experience, you get the frustration of the reality there. You got to decide, well, maybe for my regression, I don't use all 6 months. I use only the past 2 months because it seems to be on a trend up before it was on a trend down. And if I use the whole 6 months, it's going to be overall a trend down. But I see that recently it's been going up. I want to use the more recent data. So there's a combination. It's an art and a science. It's an art and a science. And you're not going to be as accurate as, when you first look at it, you think you should be. We'd like to be like 95, 98, 100% accurate. Well, oftentimes that's not the case. But if the percent error is small and acceptable to you, then go with it. But you could also research other ways people forecast stocks. Stocks, they look at, into the future, you look at a lot of, well, if their new, cancer drug is as good as they say it is, their stock could go up. That's kind of the qualitative stuff that you don't know about. Or we know that the Chinese are coming into the cell phone market. What's that going to do if they haven't really entered the U.S. in a big way in cell phones, and they have some pretty big companies. What happens if the Chinese enter the automotive market? Is that going to affect General Motors and Ford stock? You can't buy a Chinese car here yet. Eventually you will. When that happens, it's going to be a day of reckoning, I would think, so that's all that kind of like market intelligence information. Some people only look at market intelligence. Other people look at some people only look at the market intelligence and don't look at history. There's some other people that do what they call mini arbitrage or micro nano arbitrage. I'll fix that later. In which they're trying to say, I'm going to make a trade in the next fraction of a second. and I'm going to buy stock ABC, and it's at $100. And if it goes up 4 cents, I'm going to sell it immediately. All within a second. You can't even push your buttons on your computer fast enough for that to happen. So it's a program trading. And so you have, those people have some pretty sophisticated algorithms to see, is this stock going up? And makes instantaneous decisions to maybe invest $10,000. And if you make 4 cents on $100 share of, and you got $10,000 worth of investment in it, figure it out. What is that, 400 or 4,000 or something? Probably 400. But if you make 400, 500, 600, 1,000, $10,000 every 5 seconds, that sounds like a good deal. Also, but you're also going to lose the same amount because you can't predict exactly what's going to happen. You've got an algorithm, a scheme that you think is going to work, but will it work? So what you want, a scheme that works 70, 80% of the time, then if you do it right, you could make some money. But the market is, the stock market is a fickle little thing. Even when you think a stock should go up, they made a big announcement about this, that, or the other thing. Will it? Will it do what you think it's going to do? So that's what I want you to explore a little bit in that. How do you apply forecasting to something like a stock market? All right. Did we learn a little something about forecasting? Can you go out right now and get a job in forecasting? I don't know. They'll teach you the ropes. They'll teach you, you can go in and you have some knowledge of it, some idea of what it's about, and then they'll teach you the rest. They're not going to hire you to run the department, but they're going to hire you. They could hire you to work in the department as an analyst. So, all right. Go forth. Good luck tomorrow. Good luck Saturday. All right. And get some sleep. What? I'm going to close the video. I'm going to post it too. I'll post it in an announcement. I just got to remember to do it. Thana, thank you for your contributions today. All right. Look forward to seeing you on campus at some point.